Hi, we are Team Atomic Robot and now we are going to start our live outreach. First I am going to explain about Chandrayaan. Chandrayaan is the first lunar mission sent by Indians. It contains a very important object, that is Moon Mineralogy Mapper, which is sent by US to Indians. This is the original position, original figure of Moon Mineralogy Mapper without any gold foil covering. So, Moon Mineralogy Mapper have found water molecules on lunar surface. This excited us a lot and it shows scientific development. So we have tried our level best to make our lunar landscape very realistic.
Hi, I'm Shashank from Team Atomic Robot. I'm sure my friend Karthik told you that we try to make our landscape as realistic as possible. In an effort to do so, we have chosen a realistic crater, that is the Shackleton crater. This crater is very unique because it is very cold at its center and extremely hot at its peaks. This is because there is no sunlight at the center while there is lots of sunlight at the peaks. Due to this, the surface is also very uneven and we can show lots of scope for scientific development in this area. By finding out the geography of the locations which are hot, we can predict other locations which are hot, and by finding out the geography of the locations which are cold, we can predict other locations which are cold. And so, like that, our robot will take pictures of the surroundings. It can even catch ice samples, and hence we chose Shackleton crater.
That position is not right. Not right.
Temperature this is?
Keep it down a little bit, hold it down.
6.
6 is the lowest temperature. Let us show Vishnu. Keep it. It's okay, keep it.
That position is not right. Then what?
Start from the start zone. When we clicked, our robot immediately started. Now our robot went up the high ridge ramp. Our robot without any problem entered the water ice tunnel. Our robot had lowered its arm when it detected water ice. Our robot had seen the water ice and had collected it inside its small basket. The video of the robot was continuously on, so it has obviously taken picture of the surroundings. This is this. Okay. Now our robot has collected the solar panel worth 10 points. Our robot has carried the solar panel back to the base. That is the end of the asteroid zone. Our robot has entered the high temperature zone. Our robot has recorded the temperature at the high temperature zone, which was 53 degrees Celsius. Our robot has taken pictures. Our robot has detected the asteroid. Our robot has automatically taken pictures. And our robot has also collected the asteroid sample inside its box. And so, like this, we have completed every mission plus extra mission of collecting temperature at the water ice zone also, which was 6 degrees Celsius. And so like this we have got this. We are at the Birla Science Museum. I have tried many chases for my robot and I found that 2 wheels in the back and 1 rotocaster wheel in the front was the most useful. A rotocaster wheel is very special because it has rollers on the side that allow it to maneuver easily. We have also used very simple ideas, considering a simple box where everything falls inside and a simple shovel to pull all the things and throw them into the box. With such simplicity, we can always ensure the performance of our robot. One of the most difficult things was the center of gravity. We have a camera in the back which is very heavy, and in order to maintain the center of gravity for our robot to go up the ramps, we have kept a motor at the top. The motor at the top at a very high height has balanced the robot, and the robot is able to go up the ramps. I have used one idea from Birla Science Museum experiments. What they are that if you keep weights farther from the center of gravity of an object, they will, for a wheel mainly, they will roll faster down the ramp and slower up the ramp. And so like this we can say we can keep the stability of our robot up the ramp, and at the same time we can make our robot move fast down the ramp.
As there are 3 ultrasonic sensors, right and left ultrasonic sensors are used to follow the wall, and the front ultrasonic sensor detects the obstacle and collects it exactly. So we need a program to determine this wall follower. This wall follower program is derived. Now I am going to show the derivation.
We are going to explain how we wrote the wall follower program. The most important concept is that the power is directly proportional to the distance. In other words, the distance that the robot is from the wall is directly proportional to the power of each wheel from the wall. In order to explain this program even better, we are first going to take certain variables. First is power. Power that is represented by capital P is the power that we need so that the robot is at a constant distance from the wall. Then P0. P0 is the initial power of the robot, which is decided differently at different places. It can be 50, it can be 30, or it can be 75. Then we go for D. D is the distance of the robot from the wall. D is the ultrasonic sensor senses this distance. At the same time, we even go for another variable, that is the D0. D naught is the distance that we want our robot to be from the wall. Now as we have told that power is directly proportional to distance, we can also say that the change in power will be directly proportional to the change in distance. Like this, we have told that P minus P naught is directly proportional to D minus D naught. We have learnt that in order to take out a proportionality symbol, we must add a constant. So P minus P naught equals to K into D minus D naught. At the same way, we can say P equals to P naught plus K into D minus D naught. And this is how we have derived our equation for the power of a robot. We have used multiple math blocks and have used with only one variable for this entire equation, which has helped us a lot. And we have different speeds for different motors. Thank you.